to find the area under a curve. And then we introduced the integral, and we said really integral just means area below a curve. And we can find that exactly by taking the number of rectangles to be in and letting n go to infinity. But obviously, we have found this is a very time-consuming process. So today, we are probably going to get to some properties that should help us with this. The first property I want to give you is if I say the integral from b to a. If you need to flip those for any reason, you can do that just by pulling a negative out in front. So if we want to go backwards, that makes our integral a negative. So if you flip your upper and lower limits, you can do that anytime you want, just by putting a negative in front. Second problem. If our starting and stopping point are the same, what do you think the area under that curve would be? 0. If you don't actually have a chunk, if I start somewhere but then I never go anywhere, that's 0. So anytime it turns out with the same upper and lower limits, you don't have to work out anything, you can automatically say that would be a 0. Third. Okay. If I say capital F, what does capital F represent? Antiderivative. We've done antiderivatives, right? Well, it turns out that an integral is an antiderivative. And so, if I want the exact area under the curve, you do not have to do the whole limit as n goes to infinity of the sum thing. Okay? It works, but a result of that is we could just find the antiderivative of the function and plug the lower and upper limits in. So you plug in your ending point, you get an answer, you plug in your beginning point, you get an answer, and subtract those. And that will give you the true area under the curve. So, let's look at a problem. This is one we did a couple times already. We did it yesterday, I think, with the midpoints. We used the midpoint to estimate it. We calculate it as n goes to infinity. So what we have to do here is the antiderivative of x squared. So what do you do for an antiderivative? Add 1 to your exponent, and then we have to put a 1/3 in front. Okay, I want to talk about something. When we did antiderivatives before, we always put a plus c on the end, right? What we are going to end up doing, because I have limits, this would be what's called the indefinite integral. If I didn't have the starting and stopping points, this would be my answer. Because I have these starting and stopping points, a lot of times we'll put a vertical line and put 0 to 3. So that tells me I'm going to evaluate it. So you have to plug in 3, plug in 0, and subtract those things. So if I plug a 3 in, 3 cubed is 27 times 1/3 is 9 plus c. If I plug in a 0, we get 0 plus c. What do you end up doing with those constants? Yeah, they're going to cancel out because you're subtracting them, and we just get 9. If we have a definite interval, if we have these limits, you do not have to put the plus c, because every time when you plug in your upper and lower limit and subtract, those c's will drop off. So from now on, if I have limits, if I have these numbers, I will not put the plus c, because it's always going to cancel out. So the exact area under this curve is 9. And that was way, way, way faster than anything we have done before to find these. Let's do some more. I'm going to change that one. Let's say I want the interval from 2 to 6. 1/2 x cubed plus 3c. So we start out, what's the antiderivative of 1/2 x cubed plus 3? So what do you do with your x cubed? So that means we need a 1/4 in front times the 1/2 that's already there. 1/2 times 1/4 is 1/8. Plus, what's the antiderivative of 3? Just gets an x. And we're going to evaluate this from 2 to 6. So you plug a 6 in. Minus, and plug in your 2. And what do we get? What do you guys get? So that is the exact area under this curve between 2 and 6. Any questions so far? What's the antiderivative of sine? Negative cosine. We're going to evaluate that from 0 to pi. So that means we have a negative cosine of pi minus negative cosine of 0. Cosine of pi is negative 1, so the opposite of negative 1 is 1. Cosine of 0 is 1, so minus negative 1, and we get 2. So this is the exact same thing we were doing on that questions 10 through 14 on last night's homework. Just takes a fraction of the time by doing the antiderivative. I want you guys to try one. For the fifth. Evaluate from 0 to 2. You do have the option, if it's just a coefficient, the 1/6, you could even pull that out in front and then just do 2 to the 6 minus 0 to the 6. It'll work out the same. So 2 to the 6 is 64. So you get 64 over 6 or 32 over 3. Bless you. Did you guys get it?
Yeah.
Let's keep trying some. So, antiderivative of 2x. X squared. Minus antiderivative of x to the negative 1/2. So if you add 1 to the power, that's x to the positive 1/2. What do we need in front of that? 2. We always put the reciprocal in front. Minus antiderivative of 3. 3x, and we're going to evaluate from 1 to 9. So plug in a 9. 9 squared is 81. 2 times 9 to the 1/2. So the square root of 9 is 3 times 2 is 6. 9 times 3 is 7. 1. So we get 48 minus -4 to 52. You guys are not nearly as excited about this as you should be. How much time is this saving us from what we have been doing? You should be happy. You should think this is really cool. You guys are letting me down. Come on.
It's early in the morning.
I'm just lost for words. It's so good.
That's better.
I got it. It's like 6 days ago.
All right. We're going to do a few more. Sometimes before you do an antiderivative, you need to simplify. You know, if I gave you something like x times x plus 1 squared, you would probably want to multiply that all out before you did your antiderivative. We remember that from before, that it's a lot easier. We don't have a product rule in reverse or anything like that. So in a situation like that, you want to multiply it all out. Here you can, but to the third power means we would have to put this 3 times and multiply. So it's going to take a little bit, but we can kind of do this one in reverse. It's like a chain rule in reverse. So you add 1 to the power, and we think about when we do the chain rule, the inside doesn't change. So that's still a 2x plus 1. Okay, so if you did this derivative, the 4 would come down, so we need something to cancel that. So we have to have a 1/4. Inside would stay the same, subtract 1 from the power, and then you would multiply by what? If you did this derivative, you would do the derivative of the inside, which is 2. So what do I need to cancel that? A 1/2. So this is a 1/8 times 2x plus 1 to the 4. So for simplifying purposes, you can factor out, or that 1/8 can just come out in front. So we would have, if I plugged in a 1, 2 plus 1 is 3 to the 4th, minus, if you put in a 0, 1 to the 4th. So that's 81 minus 80, or sorry, 81 minus 1 is 80. So we should get 10 for our final answer here. So we can do the chain rule in reverse, but if it's just like a product or a quotient, you need to simplify them before you do your antiderivative. Couple more. Antiderivative of sine 2x. What's the antiderivative of sine? Negative cosine. When you did the derivative of that, the angle wouldn't change. But, because the angle isn't just x, you'd have to multiply by the derivative of the inside, which is 2. So what do I need to cancel this? A 1/2. So I need a negative 1/2 cosine 2x from 0 to pi over 2. 2 times pi over 2 is pi. 2 times 0 is 0. Cosine pi is negative 1. Cosine of 0 is 1. It's okay to have negative answers on these because a negative just means it lies below the x-axis. So positives and negatives are okay. You can also get a 0 if you think about something that has the exact same amount above and below the x-axis. That would cancel out. So 0 is a possible answer. I cannot just do the antiderivative of secant times the antiderivative of tangent because we don't have a product rule in reverse. But does anything have a derivative that is secant tangent? The derivative of secant x is secant x tangent x. So this antiderivative is just a secant of x. So when we do this, pi over 4 is like 45 degrees. Secant is the reciprocal of cosine. So cosine of 45 is radical 2 over 2. So secant would just be radical 2. Secant of 0. So cosine of 0 is 1. So secant would be 1. So radical 2 minus 1. Last one. The square root is the same as what power? So if we add 1 to the power, 1/2 plus 1 is 1/2 plus 1. So what would you have to put in front? So when you did this derivative, exponent would come down inside stays the same, subtract 1 from the power, times derivative of the inside, which is 3. So to cancel that, we have to have a 1/3. So we get 2/9 times 3x plus 1 to the 3/2. I'm going to evaluate that between 1 and 5. So the 2/9, we can just bring that down. 3/2 just means like a square root cubed. So if you put in a 5, you get 16. If you put in a 1, you get 4. I'm trying to work these out without relying on my calculator to help you guys practice some of that stuff. Square root of 16 is 4, to the third is 64. Square root of 4 is 2, to the third is 8. So you get 2/9 times 56. So, we have done the majority of this this section. The homework is a handout. Tomorrow I will finish the